Okay guys, so this is an introduction to section 5.5 called U substitution. And U substitution is basically undoing the chain rule. So let's do a little review here. If I wanted to take the derivative of x to the third plus 9x to the fifth power, how would I take that derivative? I would bring down the 5. The stuff inside doesn't change at all. This stays the same. Okay. Subtract 1 from the power, I get 4. And then I need to do what? The chain rule says you multiply by the stuff inside. And the stuff inside, the derivative of that is 3x squared plus 9. Now, when I first covered this concept, one of the things that I did was I talked about the fact that there's an inside function and an outside function. And so what's the inside function? The inside function is u equal to x cubed plus 9x. It's the inside function. And then the outside function is y equals u to the fifth, right? And so then if we wanted to take the derivative, we'd do dy over du, which is 5u to the fourth. And we would take the derivative here of u, which is du, which is du over dx, which is 3x squared plus 9. And then if you wanted to find, if this was y, this whole thing was y, right? So you wanted to find dy dx. I mean, how would you get that? You would just multiply dy du times du dx, right? And so what that would do is that would give us 5u to the fourth times the group 3x squared, you got to group it, plus 9. And then we replace the u with what it stood for, which u stood for x cubed plus 9, right? And then to the fourth. And you guys still do this sometimes as your chain rule. And same thing. That's how we do the chain rule, right? That's the very basic broken down way of doing the chain rule. And there's nothing wrong with that. And it's a great way to think about it. And that works. So now if I wanted to undo the chain rule, I want to go backwards. Well, obviously with a problem like this, if I already know the answer, right? I already know what this is, whose antiderivative that is, because I just found the derivative, right? This would be x to the third minus 9x to the fifth, and then of course what? Plus c. We always got to have that, right? But that's only because I already figured this out and I started with this. And normally I'm not going to have that, and that's not really even fair, right? So there must be a way of working backwards, and the way that we work backwards with this is we think of the u idea. Okay, so just like before, in order to invoke the chain rule, we had to know what the inside function was, right? So here, when we look at this, we look at this guy and it's inside of another function. This is inside parentheses, but it's not really inside of anything else other than parentheses. X cubed plus 9 is inside of another function. And so if I choose u to be x cubed plus 9, because remember, there's no product rules. This as it stands, if I don't know, right, if I don't know that this is the actual, I'd put my hand over it. That's what I would do in class, right? I would put my hand over this. You get the idea. I'm trying to ignore that for now. If you didn't know that was the answer, you couldn't just get it, right? You have to do this process. So what I'm trying to do here then is I'm going to say, okay, well then if u was equal to this, then if I plug that in, I get the integral of 5u to the fourth, but then I have all this stuff. Well, now I have a really big mess, because now what I have is I have u's and x's, and that's totally not allowed. I can't have multiple letters in here. I'm not able to handle that. If you want to do that, go on to Calc 3. Then you can talk about multiple letters, no, multiple variables, but we don't have that right now. So if I'm going to go u, I got to go all u. Well, guess what? If I know u is equal to x cubed plus 9, I can also find du dx, right? I can take the derivative. Let me go to the blue. here, keep it in blue. So that gives me what? 3x squared. I copied something down wrong. Hold on a second. Wait. 9x. This was 9x, which means this should have been 9x. And so this should have been 9x. Okay. So sorry about that. So the derivative here is 3x squared plus 9 in parentheses. And then if I multiply both sides by dx, right, then I can say du, because du is all I have. I don't have dx's. I have du and dx. All right. Du is equal to what? It's equal to 3x squared plus 9 dx. And look, magically, that's what's sitting here. Which means what? If du equals exactly this, and this is here, then what can you do? If I tell you that x equals 7, everywhere you see an x, you can plug 7 in. Well, if I tell you du equals all this stuff, and I have all this stuff just sitting here, then I can replace all that stuff. I can replace all that stuff with du. Okay, this is what's known as a change of variables. I have not changed the integral, and I have not done any calculus. Except over here I did a derivative, right? But I really haven't done any calculus here. But this isn't really algebra either. I'm just changing the letters, but I'm replacing. You can't just change them, and that's the problem with this title. It's not really change of variables. It is substituting one thing for another that is equal. Just like up here, we changed to u, but only because u was equal to x cubed plus 9x, and so I didn't change the meaning, I just changed what it looked like. And that's what I'm doing here, is I'm just changing what it looks like. This is not one of my rules. Is this one of my rules? Is there a rule that works here? Absolutely. Right? So now I can do the rule. If you change your variables to a different letter and you don't get one of your rules, then you wasted your time. You got to start over. All right, so what's the rule here? The 5 comes along, you add 1 to the power, divide by the power, plus c. The 5's divide away. And then it's not about u. U was a wonderful catalyst to make things work, but it's not about the u. And so what do I have to do? I have to replace the u. What was u? U is x cubed plus 9x. And that was raised to the 5th power plus c. And that is exactly what the answer was supposed to be based on our previous work right here. All right, so this part right here, that's the answer only because we did it up top, right? Only because it came from up here. But we would not normally know this answer. We would not know this, which means we have to then go through these steps, right? I have to choose this idea of u, and then I have to plug it in. And then I have to find out what my derivative du looks like, and then I have to plug it in and hope that it matches. If it doesn't match, guys, you can't force it. You can't just change from x to u because you feel like it or because you know you're supposed to. Something's got to happen where you're allowed to do that, okay? So the process here takes a lot of practice. This is a time in the classroom I would be shaking keys and yelling and banging on the door and stuff like that. This takes a lot of practice. You can't get around it. This takes even more practice than doing the chain rule. It takes a lot of practice, okay? So here's the idea. For those of you that kind of like a formula, here's the idea, right? The idea is this, we have the integral of some function that has another function inside and is also multiplied by the derivative of the inside function. So if we call u g of x, then the derivative and then I'm going to take the dx to the other side. The derivative is g prime of x dx. And so this is replaced by du, and this is replaced by u, and so you can rewrite this as the integral of f prime of u du, and then the antiderivative of the derivative is just f. And then what do? You substitute back in for u and put the g of x back in there so that we end up with x's. If you start with x's, you got to end with x's. If you start with t's, you got to end with t's. Doesn't matter what the letter is. All right? If you start with u's, that's not good because then you have to change letters to do u substitution. But that's the idea. Okay, so this is what's known. All right, this process is known as u sub or u substitution. But guys, don't rush it. I'm showing you every step. Do every step. Students that struggle with u substitution either don't know the chain rule and then they don't have a lot of hope at this point. But most of you guys know the chain rule, so that's not the issue. The other issue is that you try to do the u and the du and collapse everything at one time. Don't do it. Trust me, take every step. You should mimic what I'm doing as I solve these problems. So I'm going to solve 3 problems. Then I'm going to create a second video that is me solving about 6 more problems. And I'm going to post it also on YouTube afterwards. It's just going to be extra examples because you can't do enough examples of this. And then you guys are going to do as many problems as you can from the copious number of problems available because I've already uploaded like 3 u substitution worksheets. And there's a bunch of problems on there. Okay? So let's take a look at what this might look like. So I want you to see these 3 examples. I've got 3x to the 4th plus 4x squared, 12x cubed plus 4. I've got 3x to the 4th plus 4x all squared, 4x cubed plus 1. And I've got 3x to the 4th. This is supposed to be the same exact thing here. 3x to the 4th plus 4x squared dx period. All right? So notice they're very, very similar. They all have the same kind of basic thing. They all have the same thing. All right? So when you first look at this, your question is, does this look like one of my rules? Absolutely not. It doesn't look like one of my rules. And so then I've got to say, okay, well, I probably need to do a u substitution. So your choice for u, it's not always perfect, but probably 95% of the time. If you have a function inside of another one, right? I have stuff squared. So I have a function inside of another one. That's a good choice for you. All right? So let me tell you this up front. You will make bad choices. It's life. It happens. And you will make bad choices in calculus. You will choose the wrong u sometimes. You have to recognize when that happens and not quit. Calculus is not for quitters. You must go back and try something else. Okay? Or, and it might be u substitution and it might be just do some algebra and we'll see that. But you need to make sure, all right, that you do not force it. If it's not one of your formulas, try something else. All right, so what is the obvious choice here for u? What's inside here? U should be the stuff inside the square, 3x to the 4th plus 4x. That should be your u, okay? So now, here's what's going to happen. I am going to go ahead and write down, right now, I'm going to replace this with a u. And there's 2 reasons I do that. The first reason is I want to see what I have left. I need to see what I have left. Because when I take the du, that has to take care of pretty much everything else. If it doesn't, I'm in trouble. All right? So I plug in the u, I look and see what else I have left. Okay? Now I take the du. So notice how we're doing this. We pick a u over here, then we come back and plug it in. Then we go over here and check the du. And then we're going to see if we can plug it in. Okay, well, it just turns out, take this derivative, you get what? You get 12x cubed plus 4 dx. This is exactly what I have here. Perfect match. And so what I'm going to do is I'm going to replace this whole thing. This is all equal to du. So I can replace du. Because if it's the same, then I can replace it. So I get u, all right, squared du. So again, first step is choose the u, then plug it in. Second step is to calculate the du, then see if it plugs in. So you choose this, you don't get a choice of that, right? That's just the derivative. You can't choose that. If it doesn't match, you did something wrong. Or you got to manipulate it, one or the other, okay? So now, here's the key step. Is this u integral one of my rules? Remember what I said? You cannot do anything other than the rules. So is this one of your rules? Sure it is. It's the power rule. U to a power. So what do you do? So is it one of my rules? Yes. Then I do the rule. All right. Anybody like Shrek, the movie? Shrek 2, the little kid at the beginning, and Shrek's at the birthday party, and there's a little kid on there who's like, do the roar, do the roar. All right. So do the rule. Do the rule. And so what's the rule? It is add 1 to the power, divide by the power, plus c. All right, and then the last step is go back. Go back to x, or whatever the variable is, okay? Another way to put that would be it's not about you, right? I don't want my answer to have a u in it. I want my answer to have whatever the variable I started with was, and that was x. So I get 1/3, 3x to the 4th plus 4x all cubed plus c. And this right here, this guy is the family of antiderivatives whose derivative is this big mess. And if you took the derivative here using the chain rule, you would get this stuff right there. Okay? So for problem number 2, how does problem number 2 differ from problem number 1? Well, you get the same basic stuff here, but this is different. Let's see how that plays out. I'm going to try the same rules. I'm going to try the same process. Step 1, choose a u, and my choice of u is whatever's inside of another function, and so there's really only one choice. It's 3x to the 4th plus 4x. Okay, so I'm going to end up with this is equal to the integral of u cubed, or u squared again. But this time I have a slightly different thing here. This is 4x cubed plus 1. Okay. And then when I take the derivative over here, I get the same thing. I mean, it's the same function. I better get the same thing. So I get 12x to the 3rd plus 4 dx. Okay. Is this what I have over here? No, it's not. It's not what I have. Can I make it look like this, though? Can I make it look like this is not, I don't think I copied this down right. All right, so this guy should have been a 3x cubed. Just bear with me here. Okay, still not the same, still not what I have, right? Still not at all what I have. But what do you notice over here? This has a 12, this is a 4. So I could algebraically, I could factor out a 4, right? I could factor out a 4, and if I factored out a 4, I would be left with 3x cubed plus 1. So I do have this, I just happen to have 4 of them, and over here I only have 1 of them. I don't have 4, I only have 1. Well, that could be a problem, but it's really not, because if I divide both sides by 4, right, then I end up with 1/4 du equals 3x cubed plus 1 dx. And since this is over here, I can substitute in this. I can't substitute in du, but I can substitute 1/4 du. We'll see if that works or not, but I might as well try it. Right? So I get the integral of u squared times 1/4 du. Now, what is 1/4? 1/4 is just a number. It's a constant. What can you do with constants? Bring them out front. Constants come out through this sign. They can come out. Is this one of my rules? You bet it is. The 1/4 comes along. I get u cubed over 3 plus c. All right. And then what happens here? 4 times 3 is 1/12. And then substitute, it's not about u, plug back in, 3x to the 4th plus 4x to the 2nd. And that's my antiderivative. So really the only difference between this one and this one was there was a 4th missing. And so this is 4 times as much as that one. But you can handle that. You can do u substitution if when you go to get the du, the only thing different is a constant. If the only thing different is a constant multiple or division by a constant, then you can put it to the other side and you can pull it out of the fraction, pull it out of the antiderivative symbol. You can't do that with variables. You can't do that when you're adding and subtracting, only when you're multiplying or dividing. Okay? So if you take a look at number 3, all right, I'm going to kind of move ahead here a little bit because I want to show you something that if I go here and try to do u again, just like I've been doing, because it looks like the same basic problem, I'm going to get the same du again because it's the same basic problem. Oops, there's not supposed to be a squared there. It's just 4x all squared, right? This is u. I end up with u squared dx. And then I can't do this. This is what I can't do. So if you're taking notes at home, be ready to scribble this out. This is what I can't do, because if I try to do this and I substitute that in, I'm going to have x's in here. And so I can't have x's and u's together. So then if I try to take this out like that and try to take it out front, that is a big fat no. Can't do that. Why not? Because you're not allowed to pull anything other than a constant out through this sign. And this is not a constant. This is a bunch of stuff, right? This sign, those of you that are in biology class, you know this. Think of the antiderivative symbol as a semi-permeable membrane. You're allowed to pull out, some stuff will come through it, but it has to be real simple, right? Complex things like variables, like expressions. Those are too complex, those are too big to pull out. Can't do it, right? So this is not the way to do this problem. This is not the way to do this problem. And you have to, by experience, now I don't expect you today, but by experience, eventually you have to recognize that if I have problem number 3, which is the integral of 3x to the 4th plus 4x all squared dx, and that's all I have, and I try to do u substitution, I get stuff that I don't have to replace anywhere, and I can't do that, then there must be another way to do this, and actually we did one like this, right? What do? You FOIL it out. I think of this as 3x to the 4th plus 4x times 3x to the 4th plus 4x. And then I do algebra, FOIL it out, I get 9x to the 8th plus 3 times 4 is 12 plus 24x to the 5th plus 16x squared. All right, and then I just do my rules. This is x to the 9, 9x to the 9 over 9 plus 24x to the 6 over 6 plus 16x cubed over 3 plus c. And so these will simplify down a little bit. Okay, but this is a problem you could have done over the weekend, right? This is not U substitution actually at all. But your job, again, not now, but eventually, will be to recognize these well enough that you can look at number 1 and number 2 and say, oh, those are basically the same problem. That's U substitution. But oh wait, problem number 3, that doesn't have the extra stuff I need. That must not be remember, U substitution is undoing the chain rule, so you got to have an extra piece, and this is not got an extra piece. Okay? So that's the idea of undoing the chain rule by using what's known as U substitution. Okay, so U substitution is a really important idea, and we need to be able to handle U substitution, and you need to not try to do it in your head. You need to really do U substitution all the way out. Okay, so I am going to create another video that has about 6 examples of different types of things that you might see. All right, but I want you to see one more idea, one last example before we go here. And that is a simple one. Sort of simple, okay? So what if we have the antiderivative of cosine of 8x? So technically, what do we have here? We have a function inside of another one. We have a u. Now that is only an 8x. It's not much, but it's more than just x. If it's just cosine of x, do the rule, but it's not. And so what you have to do is we have to plug this in, cosine of u now, all right, and then take the derivative. So first thing I do is this. Second thing I do is I take the derivative, du is 8, just 8. Do I have an 8? I don't have one. So I got to divide both sides by 8, and I had a dx here. I replaced my u, this is still dx. Now, I'm solving for dx, so I have 1/8 du. So in place of dx, I put 1/8 du because that's what it is. And then what can you do with the 1/8? The 1/8 comes out front. So now the question is, does this look like my rule? Right here. Sure it does. It's exactly the rule. So what do? Do the rule, right? We do the rule right now, but the 1/8 is still out front. So what's the rule for cosine? The antiderivative of cosine is sine of u plus a c. And then of course we have to go back to black here. We have to go back to x. So we get 1/8 sine of 8x plus c. Now as you get better and better, you may be able to jump a couple steps and get down here quicker, okay? But trust me, if you skip the 8 part and you just give me sine of 8x, you forget the 1/8, it seems like you're almost exactly right anyway. You just missed the 1/8. Well, guess what? You're totally wrong, right? Because if you're totally wrong, because you broke the rules. The rules do not, you don't have a rule for cosine of 8x. You have a rule for cosine of just u or just x, depending on the letter. But not for 8 of them. Okay? So be careful. Even if it's just a 2x plus 1, even if it's something real simple that's inside of another function, you're most likely undoing the chain rule, and so therefore you need to use U substitution, and that's the way it works.